Okay? So what's our main identification assumption here? What's the big assumption we have to make? It's that we don't have students sorting to teachers based on these unobservable components epsilon. That is, we can't have it be the case that a particular teacher always gets students who have positive epsilons or negative epsilons on average. That they're not always getting the kids who are better than they look on paper or are worse than they look on paper. That's a problem for our analysis, and that's what I'll spend a lot of the time today trying to convince you is not happening in the data. Okay? And then, once we have this value-added measure, what can we do with it? Once we have a value-added measure, we can take another outcome, a long-term outcome, and this doesn't have a G subscript on it because, like I said, it's your earnings at age 28. So that's not different between grade 4, grade 5, grade 6. Earnings at age 28, we're going to regress that on the value-added measure, plus the other controls that we had, and then we also have these unobservable components that I'll talk about. So let me point out two things. First, this mu j with a little orthogonal symbol on it. What I mean by that, why we put that in there, is I want to point out just something conceptual. What we capture with a value-added measure is the teacher's impact on test scores or anything else that teacher does that is correlated with their impacts on test scores. But that doesn't mean that there aren't other ways in which teachers affect long-term outcomes. So if a teacher affects your earnings at age 28 by teaching you how to sit still, right, and pay attention, that's part of probably an important skill that you need. You're all sitting down, sitting still, paying attention. That's important. Okay? So maybe you got that, part of that, from your 4th grade teacher. Okay? If that shows up in your test score in 4th grade, if that improves your 4th grade test scores because during the exam you could sit there and pay attention, we will capture that. Because it's going to be correlated with the test score-based measure of value added of teacher performance. If it doesn't show up in your test score, but it shows up in your wages, that's okay. It'll be over here. But by definition, this is uncorrelated with this. By definition. Okay? But I just want to point out that there's other ways in which teachers can affect your long-term outcomes that aren't picked up by the test. So that's why when you go to the practical issues around measuring teacher effectiveness, you wouldn't want to only measure that using a test because a test probably doesn't capture everything that teachers do that's useful. And if you have other measures that can capture these other aspects of teacher performance, you'd want to use them. Okay. So that's one thing. And then the other thing is we have this new unobservable term, which is student unobservables that are orthogonal to scores. That is, other reasons I make more money that are uncorrelated with my test scores. Right? Like, I don't know, my dad owns a factory, and I get a job in the factory. And if that has nothing to do with whether I do well on tests or not, but it will affect my earnings, that's important. Okay? So, the beta term here, the relationship between value added and earnings, that's just the covariance. Okay? And that's just going to come out of the regression. And so what's our new identification assumption here in this second stage of the analysis? It's a little bit weaker than in the first stage. What we're assuming is that teacher value added is uncorrelated with the unobservable determinants of earnings, that V term over there. What that means is that sorting to teachers on this unobservable V term, that's okay. As long as it's not correlated with value added, right? So if the factory owner's kids always get a certain teacher, okay, that teacher will always look like their kids earn a lot more money, right? But it wasn't due to them, it was because it was the factory owner's kids. Always like to get her. That's okay, as long as the factory owner's kids aren't being sorted to a teacher that has necessarily high or low value added. Okay, so it's a slightly weaker technical assumption, slightly weaker. The substitute comes in, Torres comes in, and teaches in grade 5. If Torres is supposed to be very high value added relative to Xavi, then overall, average test scores across all 5th graders, not just their 5th grade classroom, but all 5th graders, should go up. And that's what I'm seeing here. This is just made up data, right? This isn't an example from the thing. And then we should also see earnings going up later on in life. Okay? That's what we're going to test for later. But that's the idea. So are people clear on why this is, how this is different, and why we no longer have to assume that the kids that you're getting in your classroom are somehow randomly assigned to you, right? We're not using that classroom level data. We're using the whole cohort. Okay. So this is an example of that idea. We take all, this is just showing you a subset of the data. It's around 1,700 events where a really high value-added teacher, according to our measure, shows up in a particular grade. Okay? And what we do is we say, let's look at test scores, this in the solid line. Let's look at what happened to average test scores in that cohort. No control variables. This isn't a regression. This is just raw data. Average test scores in that grade were going along, not trending up or down. Okay? That great teacher shows up, and all of a sudden, boom, average test scores go up in that grade. And they stay up in the following year. Okay? Now you might say, okay, but why did the great teacher show up? Maybe she showed up right when there was a big change at the school. A new director came in. They changed which kids were being assigned to that school. They assigned them kids from a better neighborhood. Right? They changed policies in some other way that made it attractive for that great teacher to show up. If that was true, then 5th grade, let's say the grade where she teaches, shouldn't be the only one where test scores rise. They should have gone up everywhere in the school. Well, this dotted line shows test scores in the grade directly below the one the great teacher went to teach in. Nothing happening. Nothing happens in that earlier grade. Just in the grade she teaches in, that's where we see the increase in test scores. Okay? Now, we can do this for a great teacher showing up. We can also do it for a great teacher leaving, a bad teacher showing up, and a bad teacher leaving, and I'll show you that now. This is a great teacher leaving. We can see now there is a bit of a pre-trend. Great teachers tend to leave schools where test scores are trending down, but they're trending the same in the grade she teaches in and in the other grade. But when she leaves, test scores drop in the grade that she was teaching in, and drop by much more than they drop in the grade below that. This is a bad teacher, according to our metrics, showing up. A low value-added teacher. Where do these bad teachers go? They go to schools that are already having problems, but when they show up, the test scores in the grade they go to go way down, whereas the test scores in the other grades don't. This is a bad teacher leaving. Bad teacher leaves, test scores improve. In the grade below that, nothing happening with test scores. Okay? So this isn't an experiment. I can't tell you why the great teacher showed up or why the bad teacher left, but this does give you at least some evidence on the question of what would happen if you fired a bad teacher. Right? Some evidence on that question.
Excuse me.
Yeah.
If there is a switch of teachers, imagine from the 4th grade to the 5th grade,
yes.
Then you would imagine that the good one was in the 4th grade and it is changed to the 5th grade and the bad one do the reverse. Then you will see the effect only 1 year of, for one promotion of the students.
Yes. And that's true. And we're averaging across all of those events, so there's 1,600 events there. So what we're saying is that there are probably going to be some, because what we can predict is what's going to happen that first year. What happens in future years, it's unclear whether we're going to see that depending on which configuration they switch to. There's so much different ways in which that transition happens that over 1,600 different events, that gets averaged out. Right? But you're right, in that particular instance, you might see that it goes up for 1 year, but you move that bad teacher to the next year, and then test scores go back down again. That's true. Okay? But that doesn't always happen.